Let's now walk through an example where we are going to find the volume of a solid obtained by revolving a region about the x-axis, and we're going to use cylindrical shells. The curves that we're given is x is equal to 1 plus y squared, x is 0, y is 1, and y is 2. The first thing that you want to do when you're solving this type of problem is to graph these curves. I've already done that to make things easier. Here's the curve, x is equal to 1 plus y squared. Here's the line y is 2. Here's the line x is 0. And here's the line y is equal to 1. So the region that we're going to be revolving is the region that is enclosed by that curve and those three lines. We're going to be rotating this region about the x-axis, and we're going to use cylindrical shells. And here's the formula that we are going to be using. What we need to do first is find the limits of integration. We are integrating with respect to y because the thickness of each of our cylindrical shells is equal to dy. The first thing that we need to do is to find the points of intersection of all of these curves. And because we're integrating with respect to y, we need to find the y value. Because two of our curves are lines, we actually don't have to do anything. And we can see that we're going to integrate from y is equal to 1 to y is equal to 2. So let's just mark over here, c is equal to 1 and d is equal to 2. Now what we need to do is find r and h. Our radius is right here. I'm marking this in blue. And it is the distance from the curve to our axis of rotation, which is the x-axis. So this is just equal to y. And then the height, which I'm going to mark here in red so that you can see it. And that distance, we'll mark this up here, is h is equal to x. Now we can go ahead and write down our formula. I'm going to write the general formula first. This is 2 pi, the integral from c to d of r h dy. Now we can substitute in what c and d are. C is 1, d is 2. Our radius, let me highlight this so you can see it, is equal to y. And then our height is equal to x. And we're integrating with respect to y. Now what we have to do is substitute in what x is. X is given by our curve 1 plus y squared. And let's go ahead and put that in. We get 2 pi, the integral from 1 to 2, y times 1 plus y squared dy. Before we integrate, let's go ahead and multiply this out. We have 2 pi times the integral from 1 to 2. Inside, we have y plus y cubed times dy. Now we can go ahead and integrate. This is 2 pi. We have y squared over 2 plus y to the 4th over 4. And we're evaluating this from y is 1 to y is 2. Let's first put in that y is 2. 2 squared is 4, so we have 4 over 2. 2 to the 4th is 16, so we have a 16 over 4. And then we subtract off 1/2 and 1/4. Let's combine our fractions. We have 4 halves minus 1/2, so that's 3 halves. And then 16 over 4 minus 1 over 4 is 15 over 4. Looks like we can get a common denominator of 4. So this is 6 plus 15. We can cancel the 2 into the 4. So this gives us 21 pi divided by 2. And this tells us that our volume of revolution is equal to 21 pi over 2.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.